Hi, this is Hamid-T. As I'm recording this, I just received a flash flood warning on my phone which perfectly illustrates our problem. Floods are amongst the deadliest and most damaging disasters, yet creating timely maps remain a major challenge. Despite abundant satellite data, turning them into actionable insights fast enough for, let's say, emergency response is difficult, especially when labeled training data is scarce and the events are rare. To address this, we turned to a novel architecture, the quantum vision transformer. Dr. Liu will walk us through its origin and core advantages.
Hello, this is Junyu. Quantum vision transformer is originally an invention in the quantum information science community by a paper published in Quantum Journal by a team of CNRS from France, QCwire, the University of Edinburgh, and Roche. And later, their invention has been adapted by several teams, including the quantum team from JP Morgan Chase. So what they find is that compared to a dual classical model made by so-called classical orthogonal neural networks, quantum vision transformer seems to be much better in terms of number of training parameters, with the same or comparable performance in the computational vision task found by their experiments. So it is explained later, actually in my perspective paper in the Quantum Journal, that such observation seems to have a theoretical reason in terms of sparse training theory for large-scale sparse neural networks. Thus, such type of algorithms are at least interesting quantum-inspired classical algorithms, since the number of qubits comparing to quantum fidelity are relatively cheap to scale in the real quantum machine. Those setups in the practical machine might provide good enhancement compared to classical counterparts in the current devices or in the future. So thus, my graduate student Shing and I, together with other team members, have demonstrated that this observation is indeed correct, that such the performance of quantum vision transformer in the classical simulation is indeed comparable or even better than traditional model in certain metrics.
Quantum vision transformer achieved 82% flood FS score in our experiments with 6.4 times fewer parameters than traditional deep learning. This enabled us to deploy the model on satellites, drones, and edge devices where computational resources are limited. Thank you.